Hi folks, you are already familiar with the LTSpice UI and toolbox and the basic keyboard shortcuts. In this episode, we'll construct a TTL NAND gate using two NPN bipolar junction transistors and couple of resistors. We will apply pulsed waveforms shaped like square waveforms as the two inputs of the constructed NAND gate. The square waveforms have different on time and off time to cover all the truth table combinations of the constructed two input NAND gate. We will apply proper DC biasing voltage and transient analysis to check the functionality of the constructed two input NAND gate. So stay tuned, stay focused. Hey guys, welcome back. In today's episode, we will construct the NAND gate using TTL logic. In this circuit, we will be using two BJTs and couple of resistors to construct the TTL NAND gate. Now, to draw the circuit, let me double click on the LTSpice icon and you can see the LTSpice window has opened. Now, I'll go and click on the new file icon. A schematic dashboard has been opened. Now, I will save the file with a name. Go to File, then Save As. And here I will type the name. So I will save the file with the BJT TTL NAND gate. I'll click Save. Our file is ready. We'll start working here. Now to insert the BJTs, I'll go to the Components. And here I'll click on the NPN. So this is a BJT and its type is NPN and I'll click Place. I'll place first and second two BJTs and I will right click to vanish it. Now I'll fit to screen and then I'll zoom out to place the other components. Now I'll place the resistors. I'll hit R from the keyboard. I'll click Ctrl R to rotate it. Now the first resistor is placed here and the second resistor is placed here. I'll right click to vanish it. These two resistors will be connected with the transistor base. And here for the collector I'll need another resistor. So I will hit R from the keyboard. I'll click and place it. I'll right click to vanish it. I'll zoom out so that I can see them properly. Now I'll place the voltage sources. I need a DC source for the collector supply. So I'll hit V from the keyboard and this will be placed here. Now for the two inputs, I'll need two pulsed waveforms. For that, I'll need voltage sources here. I'll click here and here. Two voltage source will be used as the inputs. I'll right click here to vanish it. Now I'll click W for the wiring. So I'll start wiring. I connect this resistor to base. I connect this resistor to collector. I'll connect this resistor to base. And this voltage I'll connect to the resistor. I'll do the same here. Now I'll connect these resistors to the collector supply. Now I'll do the connection of the two BJTs, that is from emitter to collector. Now I'll need a ground line. I'll zoom out a bit. Now I'll draw the ground line. For that I'll hit W from the keyboard for the wiring. I'll start drawing here, go downwards, go up to right, and then I'll come back again at this point and click it to finish it. Now I will connect this to the ground line. Now I will connect this to the ground line and our circuit construction is almost done. I'll right click to vanish it. I have to give the proper ground connection, so I'll hit G from the keyboard. I'll place it here. I'll hit W from the keyboard for wiring and I'll connect with the ground line. So our ground line is now proper. Right click to vanish it. Now two things are remaining, two pads are remaining, that is for the output and for the input. So here I will take the output. So I'll hit W from the keyboard to take out some of the wire and right click to vanish it. Right click to vanish it again. Then I'll get to the pad and give the name out. Here I'll select output, click OK and I'll place it here. I right click to vanish it. Then again I'll go to the label again, that is for the pad. So here I will write VA and it will be input. I'll click OK and I will place it here. Similarly, I'll go to the leveling net again and I'll give the name VB and I'll select it as an input. I'll click OK and I'll place it here. Right click to vanish it. I'll click the save button to save all the things that we have placed on our dashboard. Now all the placeholders are there. One by one I'll have to rename and give the values. So I'll rename this voltage as VA. I'll rename this voltage as VB. I'll rename this voltage as VCC. I'll rename this resistor as RB1. And I'll rename this resistor as RB2. And this will be RC. All the resistors have been named. Now let me click on save here. I'll give the values. Both the base resistances will have value of 4.7K. So I'll click here and I'll give 4.7K. And again I'll right click here, 4.7K. And the RC will be 33K. So I'll give 33K. I'll click OK. Now the resistances have been assigned. Let me choose the model for the BJT. I'll right click here, go to the peak transistor, and here I'll select this model, that is the 2N2222, and I'll click OK. Again, I'll right click here, pick the new transistor, and I'll use 2N2222. I'll click OK. So here I'll click save, and we can see that we have given the values of the placeholders of the resistances and the transistors. Now comes the voltages. For the VCC, I'll have to assign a value of 5 volt. I'll click OK here and I'll click save. So far the values that we have given will be saved. Now I will assign this particular voltage, that is the pulse waveform. I'll right click on the voltage, go to advanced, and I'll click pulse. In theoretical episodes, I have talked about the pulse and its different components, so I'll not go in that detail. Please go ahead and watch that episode from this playlist. Here I will give the values only, as this is application episode. I'll give the values here: 0, then 5, then 2 micro, then 1 femto, then 1 femto, then 4 micro, then 8 micro. So let me check and scrutinize the values. 0, 5, 2 micro, 1 femto, 1 femto, 4 micro, 8 micro. So I'll click OK. I'll click set. Now I'll right click on the VB and go to advanced. Again I'll select pulse and I'll start giving the values. 0, then 5, then it is 1 micro, then 1 femto, then again 1 femto. T on is 2 micro, T period is 4 micro. Let me scrutinize the values: 0, 5, 1 micro, 1 femto, 2 micro, and 4 micro. So the values have been assigned. I'll click OK and the pulse waveforms are done. I'll click save. I'll give the two spice direct. First is a .IC for the initial conditions here, and then I'll give the .tran. I'll click OK and I'll place it here. Now I'll right click on the tran to give the values. It is 7 micro, then it will be 0, then it will be 1 nano. So our transient analysis, the command construction is done here. I have talked in detail about the transient analysis in the theoretical episodes. Please go ahead and watch that episode in case you have zero knowledge or insufficient knowledge about the transient analysis. So here I'll click OK. I'll click save. Now I'll go to view, then spice netlist, and I'll scrutinize the circuit. I'll turn on my marker pen here. We have 2 transistors here. We have 2 base resistances, 1 collector resistances, 1 collector supply, 2 pulsed waveforms. Models are here, which are accessed from this particular .lib file. We have IC and the transient analysis. So all are done. Let me clear the screen and let me close this spice file. I'll click save again and we are ready to run the simulation. So I'll go and hit the run button. So you can see here the window has come. Before going to anything, I'll go to view, then spice output log. And here, once I check, I cannot see any error or warnings. So it's good. We will continue with the simulation results. I'll close the log here and click here, quit to screen, and here the simulation results will be there. So let me go here. First click on the VA. Now I click here and I hit B from the keyboard for making the space for the another waveform. Now I'll click on VB. Now I'll come back again and hit B from the keyboard for the third space to be created for the output. So I'll go here and I'll click the output. Now let me turn on my marker pen so that I can verify the truth table from these simulation graphs. Now for NAND, only in 1 and 1 combination the output will be 0. For other combinations it will be 1. So for 0, 0 it will be 1 and it is 1 here. For 0 and 1 it will be 1, so it is 1. For 1 and 1 it will be 0, so it is 0 now. As you can see, if I draw a vertical line, if I draw these vertical lines, you can see that is for 1 and 1 it is 0. Now for this vertical line, this is 1, this is 0 and this is 1. Again, if we go here 1 and this is again 0. So it takes a bit of transition time because it's an analog circuit and it is constructing a digital logic. We have to consider the transitions also. In breadboard, when you make this circuit, you don't see the transition, you see the LED blown or LED is off, right? When you are doing the same thing here, you will see the transitions. Let me clear the markings here, and we have verified that output waveform is conforming to the truth table of the NAND logic. So here we have constructed a 2-input NAND gate using BJT TTL logic. So our circuit construction was correct and the output also conforming to the NAND logic. So that's all, folks. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.